Hello, I'm Jialing Deng from the Research and Games Lab at Monash University in Australia. I'm here to present From Plating to Tasting towards understanding the choreography of computational food. This research is a dive into how computing technology is reshaping our dining experiences, blending culinary arts with digital innovation in the field of human-food interaction. We noticed that many materials have complex structures that can function as computational systems, and their physical properties can be seen as computational attributes. Specifically within the human-food interaction field, researchers have explored the concept of programmable food, such as embedding active structures in pasta to enable computational shape transformations as it cooks. Moreover, there have been efforts to design food items as computational artifacts that are capable of computing their own flavors. This has further blurred lines between food design and computational innovation. These advancements enable food materials to exhibit computational capabilities such as sensing and actuation. Yet we've noticed that existing designs fall short in capturing the rich complexity of human-food interactions or the nuanced dynamics in food experiences from creation to consumption. Therefore, we've taken a temporal approach, harnessing the physical processes of food to enable computational processes that dynamically evolve over time. We introduce Dancing Delicacies, a system that allows for dynamic dining experiences where meals are not just prepared but programmed by chefs and then reconfigured by diners to their liking. It's not just about eating, it's about engaging in the creative process by introducing computation into food preparation and consumption. Our aim is to cultivate novel dining experiences and deepen the connection between people and their food. We liken this process to choreography based on the traditional sense from dance, where we view choreography as the art of designing dynamics within the food journey, encouraging a rich ecology of interactions. This choreography does not just dictate movement. It sets the stage for new connections and discoveries within the culinary practices and dining. But why is this important? We attempt to craft a future where dining is deeply personal and interactive. Imagine that your meals can instantly adapt to your health and taste preferences on the fly, and dishes that dynamically respond and change to your preference, turning eating into an engaging, communal experience in a whole new way. Here we highlight our contributions to the field. First, by bringing two novel dishes from concept to reality, we've laid foundational groundwork for future exploration in computational food design. Second, we've expanded the field's understanding by identifying 4 facets of culinary choreography, broadening the scope of inquiry into computational integration with food. Finally, our discoveries converged into design implications for the future of computational food innovation, connecting theoretical inquiry with practical application in the design of human food interactions. We used Dancing Delicacies as our research artifact to further our examination of computational food, with a focus on the culinary choreography. The system enables multiple dynamic dining trajectories through operations like moving food items, combining edible liquids, and blending flavors, all controlled by the electrowetting technology. These operations allow for dishes to be programmable and reconfigurable. Through programming, a chef can set initial conditions and dynamic behaviors of a dish, such as movement or flavor merging. Reconfiguring then lets diners adjust aspects of the food based on the chef's initial settings, like changing the presentation or flavor combinations. Based on the concept, this paper aims to answer the question, How do we understand the choreography in computational food design and its impact on shaping food experiences? We present a two-phase study delved into the choreography of computational food, involving both experienced chefs and diners in the process of co-creation and dining experience. We engaged 6 chefs in 3 co-creation workshops and invited 6 diners to participate in 3 separate dining experience sessions. From the co-creation workshops, we crafted 6 conceptual designs for our Dancing Delicacies dishes. 2 of these concepts were fully realized and presented during the dining sessions. These creations not only introduced new elements into computational food, but also expanded our culinary repertoire with unique ingredients and techniques, enriching the flavor diversity of Dancing Delicacies. Through observations, working notes, and interviews, we found 6 themes in relation to the choreography of computational food. Our themes highlighted the opportunity for chefs to express their artistic flair and boost creativity through computation. This fusion of culinary arts and computational power not only strengthens the connection between chefs and diners, but also has the potential to enhance consumer satisfaction and open new avenues in the food and entertainment industries. From our themes, we identified 4 facets in understanding computational food choreography, including the unforeseeable improvisation, anthropomorphized expression, collaborative interplay, and material narrative. Together, these insights have guided us in reimagining dining by blending computation with culinary art, shedding light on implications for the future of computational food design and innovative human-food interactions. To sum up, our research of computational food choreography has not only unveiled new intersections of computation and taste, but also set the stage for a future where dining transcends tradition, inviting chefs, diners, and technology to co-create the culinary experiences of tomorrow.